Welcome to Bite-Sized Data Science. We left off our Spark discussion talking about RDDs, DataFrames, datasets, driver programs, and why you may want to use Spark. In this video, we'll go a bit deeper to get an understanding of how Spark works by looking at resilient distributed datasets. Don't worry, you don't need to be a hardcore software engineer to understand this. We said that a Spark client is a driver program that talks to a Spark server. That's not really different from you using your browser to view YouTube videos like this one or to access email. By the way, I've heard many times people say that Spark is easy. Keep in mind that it is still programming. You have to learn the classes and methods and know how to use them. As we saw earlier, an RDD is an abstraction of your distributed data. It has a few interesting features. First, it is immutable, which means that once created, it cannot be modified. This is convenient when it comes to resilience. When you execute operations that change an RDD, Spark creates a new one and keeps track of where it came from. For example, if you have your initial data in an RDD called RDD1, and you convert some fields from character strings to numbers, the new RDD, RDD2, will contain these modifications. But also remember the operation and that they operated on RDD1. So, if the creation of an RDD fails for any reason, it only needs to go back to the previous RDD and start from there instead of having to go all the way back to reading the data from disk. You may say that all these copies will eat up your memory quickly. That's possible, but Spark will manage memory and remove what is not needed. For example, if you are now at RDD3, do you really need to keep RDD1 since you have RDD2? Once RDD3 is created, do you really need to keep RDD2 around? Of course, it is a bit more complex since you could create RDD4 based on RDD1, for example. We can see that we can have quite a chain of RDDs, and with many branches, it starts looking like a tree. Let's say RDD1 is used to create RDD2 that converts a character date field into a datetime type, and then you use RDD2 and convert the salary character field into a floating number to end up with RDD3. Isn't that a waste of resources to read all the records twice? Yes, it is. There is space for optimization and Spark does it. The operations on an RDD can be transformations or actions. The creation of RDD2 and RDD3 involves transformations. Since you're not doing anything with your data, Spark notes what you want to do but does nothing. This is called lazy evaluation. Once you decide to really do something like return the average salary of all employees by department, then Spark starts doing all the transformations that are required for the action, the averages. This way, it can look at all the transformations and decide the most efficient way to get there. Why do you need to know this? That's because many people run into problems and don't realize that it is not the last action you took that is the problem, but many transformations before it. You may think, that's simple, I get it. Still, I guarantee that many of you will run into problems because of the lazy evaluation. After you spend many hours trying to figure out why your average fails and see the error in a previous transformation, you'll get it and be fine from that point on. The concept of lazy evaluation, transformation, and action also applies to DataFrames and datasets, so always keep that in mind. Here are examples of transformations. For example, you could decide to extract the distinct records from a file. This is noted, and the evaluation will happen later. If you are planning to send results back to the driver program, then it is an action and the execution must happen. When writing their code, people often add actions to their processing just to make sure the transformations are working. These extra actions can be removed once you are confident of your transformations. So, remember, Spark uses lazy evaluation, so errors can be anywhere since the last action. In the next video, we'll talk about DataFrames and SparkSQL. See you next time on Bite-Sized Data Science.